In this video, we're going to look at how to graph solution sets of inequalities. So the first example should be a review of something you've likely seen in an algebra class. Let's say I want to think about all of the solutions of the inequality 2x is less than 5. And I might want to visualize the set of values of x that satisfy that inequality by graphing them on a number line. So what we could do is start with a number line and then plot the point that satisfies the equation related to this inequality. So if I take the less than sign and change it into an equal sign, I get an equation, and I can solve that equation. 2x equals 5 implies that x is 5 divided by 2, or 2.5. And then I can plot that point on my number line. Now, normally we would plot it by drawing a circle, and in this case the circle would go right about here, but we would leave the circle unfilled like this, because when 2x is equal to 5, if I actually plug a 2.5 in, the left side of the inequality is 5, but that makes the inequality false. 5 is not less than 5. So that means the point 2.5 is not really one of the solutions of this inequality. It's just the end point for the interval of solutions I'm trying to graph. Now let's come up with the rest of the graph. So the next step is to decide whether to shade the half of the number line that's to the left of the point we just found, or the half of the number line which is to the right of the point we just found. So we've got this point here on the number line at 2.5, and either we're going to shade everything to the left or everything to the right. And we have to decide which side to shade. And the easiest way to answer that is to test a point, to evaluate this inequality with another number plugged in. And so you want to pick something easy, and so usually picking something like 0 is easy, so we'll test that point. If I plug a 0 into the inequality for x, the left side simplifies to 0, and that is less than 5, which means if I let x be 0, that is a solution of the inequality. It's part of the set of solutions. So in fact, everything that's on the same side of our endpoint will also be a solution of the inequality. If I take any number that's to the left of 2.5 and plug it into this inequality, I get a solution. So what I really want to do is shade every point that's on the left side of that endpoint. And so if I do that carefully, I get the picture I see at the bottom of the screen here. We've shaded everything to the left of 2.5, and we've left 2.5 itself unshaded to indicate that it is not part of the solution set. Okay, so our next goal is to take the same idea and apply it to an inequality that has two unknowns, x and y. And so when we do that, instead of graphing on a number line, we're actually going to graph on an xy plane, because we have to show the relationship between the variables x and y. So some points from the xy plane you can plug in, and this inequality will be true. Other points, if you plug their coordinates in, this inequality will be false. And so we want to shade all the points that make it true. So our approach will be similar. We're going to start by changing the inequality into an equality so that we get an equation we can graph. 2x plus 3y equals 12 is a line. In this case, it's easy to graph that line by finding the intercepts. If you plug in a 0 for the other variable, for example, if you plug in a 0 for y, you get 2x is 12, so x is 6. If you plug in a 0 for x, you get 3y is 12, so y is 4. And we just found the intercepts. X is 6, y is 4. And if we graph both of those intercepts, it's easy to draw a line straight through them. So all the points on this line satisfy this equation. If we plug their coordinates in to the left side, we get 12. Which means they also satisfy this inequality, because if we plug those points from that line in, if we plug in their x and y coordinates, we get 12 on the left, which is less than or equal to 12 because it's equal to 12. So all of the points on this line are solutions of the inequality, but actually there's more than just that. We also need to shade everything on either one side of that line or the other, just like we did with one variable graphing it on a number line. So we need to decide which side to shade. And our approach will be, just like we did in the previous example, to test a point. And we'll decide if that point satisfies the inequality. We will include everything on the same side as that point in our answer. Just like 0 was easy to use in the previous problem, the origin, the point with x and y both equal to 0, will be the easiest thing to test in most of these cases. So if we do that, if we test this point at the origin, plug in 0 for x and 0 for y, the left side of the inequality is 0. That's less than 12. So the inequality is true, which means if we plug in the origin, it satisfies the inequality. It's part of our solution set. And then everything on the same side is also part of the solution set. So we shade the entire region that's on the same side of our line as the origin was. And that's it. This shaded region is our solution. Let's look at another example. Let's graph the solution set of this inequality. 3x minus y is greater than 6. So we'll start out the same way by changing the inequality into an equality and graphing that equation, which is a line. Now, this time, if I take a point that's on that line, for example, if I take the point x equals 2, y equals 0, that's on the line, but it does not make the inequality true, because if I plug a 2 in for x and a 0 in for y, I get 6 for the left side of the inequality. 6 is not greater than 6. That means this point on the line is not a point that satisfies the inequality. None of the other points on the line will satisfy the inequality either. So notice the difference between this problem and the previous problem. On the previous problem, we did include all of the points from the line as part of our solution, but that's because the inequality we were looking at was a less than or equal to. And if this were greater than or equal to, we would include the line as part of our solution here. But because it's not, the line is not part of the solution. And that's why we're drawing it dashed. If we draw a dashed line, that indicates it's the edge of our solution graph, but it's not part of the solution itself. Now, just as before, we're going to need to test one side of the line or the other. And just as before, I'm going to pick an easy point to test. I'll pick the point at 0, 0. So if I plug that in to our inequality on the left side, x equals 0, y equals 0, the left side of the inequality evaluates to 0, which is not greater than 6. So our inequality would be false if we plugged in 0, 0. That means we don't want to include that point in the origin as part of our solution. We do not shade the side of the line that includes the origin. Instead, we're going to shade the other side of that line. And this is what our final answer would look like for this kind of problem. Let's do one more. We'll graph the solution set of this inequality, x plus 2y is less than or equal to 0. Start by changing the inequality to an equality and graphing the associated line. And then we want to test a point again, but this time I cannot test the origin because the origin is part of the line. And if I test a point on the line, that's not going to help me decide which side of the line needs to be shaded. We can see that if we graph this with x and y intercepts, both of them would have given us the same point at the origin. So that would not have been enough to draw this line. So instead, what we can do is use the slope of this line to graph it. If you rearrange this equation, you can get y equals negative 1/2 x. So if I start with a y-intercept of 0 and a slope of negative 1/2 x, this is the line I get. And then to test a point, we'll decide on something easy. We cannot use 0, 0, so we'll try something that's not on the line, like 1, 1, which is right about here. So that's something that can be plugged into the inequality. And when we do, we see the inequality evaluates to false. That means we do not want to shade the side of the line that has the point 1, 1. We want to shade the other side. And this is what our solution looks like.